start the session. All right. So, so how are you guys? Are you guys doing the assignment? Have you finished the previous big sessions assignment? Shrikant, did you happen to look at the? Okay, okay. And Cletus, Avdesh, Shrikant, sorry, Virana. The question was that are you stuck with the assignment? Do you need any help? Okay, okay. So in case you're stuck, you have more questions, either drop me an email or if it's a general question, then you can put it on the forum also. Great, great. So actually now you can do it on the website also. In the website you can see. Okay, so are you able to see the quiz here? Not this one, not this one, I'm sorry. Yours is this one. So here you can see the here and this one. So are you able to, when you click on it, does it open as a quiz and then you can write then and there instead of sending the email. Okay. In the website itself, you can write it. All right. So let's start now. I think most of us are already joining in. Okay. So we were at the second point probably when we left day before yesterday. So we were talking about first you launched with a perfect database with all relational, all the perfect form, as in normalized form, as in you have primary key, foreign key, you had all the sorts of constraints in place and data was perfectly normalized. So that was your initial launch. Soon your service became popular and you realized there are too many reads hitting your database. There are too many computations hitting. So for some of the data, you started caching. And for that, you implemented memcache. Memcached is a daemon which you can install on your website so that your application server can cache lot of data into memcached. Memcached is again a sort of a data store in which you temporarily put the data, and it's a network daemon, okay, which is pretty fast and shared. Now, once you do that, which means that you are pre-computing things, and the cache might be a little stale. It will take some time for any new change to propagate till the cache, and therefore the data you might be serving out of the cache might be a bit older. So your consistency is gone. So if we talk about perfect consistency, that you have anyway compromised in the second step itself. Okay? Because that's not what C of acid said. C of acid said whatever has been written should be served to the user with the latest copy. Okay? Which means no stale data. It should be perfectly, in the order in which it has been updated. Okay? Now, the next point is, so you were happy that your memcached is working fine and you are able to serve the users, and right now we have little more bandwidth to handle. And afterwards, service continues to grow in popularity. There are too many writes hitting the database. So what you do next is you scale your MySQL vertically by putting up 16 cores, 128 GB RAM, and a lot of hard drives onto this. Now your cost suddenly shoots up, and not sure if at the same cost, if you added more machines, that could have benefited more, right? So again, now you are pretty happy for some days. After that, after some time, say 6 months down the line, you keep on adding more and more features, and the query keeps on getting complex and complex, right? And you start providing all sorts of new features. Now, as and when you are adding more tables or you are making something more modular, you will have more bigger structure of the database, and hence a single query of say searching, or a single query to listing down the information would have to join a lot of table, right? There are a lot of IDs, everything has to come from a different table, and then when you're representing to the user, giving a list of products, so price has to come from somewhere, the title has to come from somewhere, the information of photo will come from somewhere, and all of this has to be combined together. And as and when you keep on adding more and more features to your database, to your application, the query keeps on getting complicated and there are too many joins. Okay, and when user accesses it, even though you have cached majority of the data, but every time user accesses it, user's access pattern, as in his search query, might be different. Therefore, you'll have to do a lot of joins every time. And this is a story about, I'm saying, around 95% of the people, be it Flipkart, be it, Common Floor, maybe. I'm not sure, Praveen. Praveen can give you a better idea. So, is Praveen in the session, by the way? Or Praveen is not there today? All right. Now, what you start doing is you start denormalizing things. Instead of putting things into two tables, you start copying the data, whatever happens after join, into a single table. Okay, just to avoid joins and joins. Okay. Now at this moment of time, same data is duplicated twice, two places, and every time a change happens in the data, you might have to update it at twice. And that's not what we were taught in the DBA school. We were taught to normalize the data. Okay. So those who come from DBA background, they must have already faced denormalization kind of a situation. They will have to denormalize a lot of things when it comes to optimization. Okay. So all of the knowledge which we carry from DBA, most of it is getting anyway. We violated acid properties, we violated now the even the normalization. Now, even after these violations, if your system grows in popularity day by day, and you should be happy about that popularity. But since we are not able to support technically, we feel sad about it, and because we are not able to handle it. Now, as the popularity grows, further things slow down, and server side. So you start doing few things, such as server side computations. You start stopping. Say, for example, you are representing time to the end user, and the time is being rendered from the server based on the time zone of the user's browser. So instead of doing this computation on the server side, you delegate it to the client side itself. Let the JavaScript render it. So a lot of things you start delegating to the browser, and you do not do a lot of computation on the server side. All right. Now, just to avoid, and similarly, you stop doing all sorts of triggers and unnecessary churning of the information on the server side. Still, some queries will be too slow. And so, what will you do is you will periodically pre-materialize. What does it mean? Pre-compute. This is a very common thing which we also did at Amazon. Lot of things we used to do the pre-computation. We use lot of things which can be prepared upfront, should be prepared and kept ready for the user instead of waiting for the user to hit our website and then we start doing computation. So most of it, if we can pre-compute, we could pre-compute it and put it in database. So which means pre-computation is a secondary data, right? When you do computations, we are keeping two sets of things. One, the actual data, and second, the computed one. So there's a duplicacy of information, but that's we do because of the optimization, and that we do it very regularly and very aggressively, just to save the user the time to access our information. So now at this end of it, you will still have other kind of problems, such as now reads are okay, but any change is hitting your machines really badly, because since you have denormalized to very large extent, now every change has to propagate first to denormalized tables, second to pre-materialization, because you have done a lot of pre-computation. So those pre-computed data has to be recomputed on every change, right? Say for example say for example we are computing the image to be shown to the user. Okay, and this image is based on hundreds of images available as of today, and the name of the files of these images, right? So every time even the name of the image changes, we'll have to do the recomputation. So there are lots of such cases where you do the pre-computation. So and every change you will have to update all the tables everywhere the data's duplicacy has happened, and therefore now writes are getting slower and slower. At this moment, you will say, and not only the denormalized data where you have to write, or denormalized and pre-computed data which you need to update, you also will have to update the secondary indexes and various other form of indexes. Say for example, you have a text search, you have Lucene indexes in place, you'll have to update those also. So every write will result in so many chain reaction that you will end up actually removing lot of indexes which are not required so urgently. So effectively, you ended up undoing lot of things what database provides. So these properties which database provided to you, such as effective normalization, a very high amount of indexes, and The acid properties are of no longer use if your website goes into a high availability and high throughput kind of a system. And that is where you realize that our database is not really useful for this website. We need to move to a NoSQL, maybe HBase or maybe MongoDB. So this is a classic example of any of the website evolution. Okay, make sense to you? So just a second. So these are the people who were supposed to join today. All right, so let me just get back to what I was doing here. Now, the next step is something called column-oriented database. Let me describe you what is column-oriented database. Then we go into the details about column family and so on. Okay. So in very simple words, when we say column-oriented, means that the values of column tend to remain together. Okay. So let's say you have a table which has got two columns, employee ID, name. So physically, column oriented database, when we say, we mean that physically all the column values are going to go together. Okay? Which means, unlike in the row oriented database, the rows values go together. So in column oriented database, you can see that for 001, that is the row number, for this is a row oriented and this is the column oriented. Now you can see here in the row oriented 10 comma Joe, then 12 comma Mary, then 11 comma Kathy. So we traverse the way we are storing this way: 10 Joey, 12 Mary, 11 Kathy. That is row oriented storage. Now the column oriented storage is, first we'll store 10, 12, 11, then we'll store Joe, Mary, Kathy. You can see, so 10, 12, 11, Joe, Mary, Kathy. Okay, that is how we store in the column oriented database. So that's exactly what it means by column oriented database. Make sense to you? Great. Now, the next one is column family oriented database. All right. In column family oriented database, the values of a column family go together. Let's imagine that column family, this table has got two column family. First column family contains employee ID, these two, these two basically. Okay. Employee ID and name belong to a single column family, while age belongs to a different column family. So the storage is going to be that the values of a column family will be stored together, such as it will store 10 Joe, 12 Mary, 11 Kathy, and then it will store 23, 33, 45. Okay, so that is column family oriented database. If age has another column family, another member in this column family, so column family is a group of columns whose value is going to be stored together. Okay, maybe compressed together, and all sorts of optimizations are done on top of it. So that is what we call a column family oriented database. As you can see, 10 10 Joe, 12 Mary, 11 Kathy has gone together, while 22, 23, 20, 33, and 45 has gone together. So that is what we call a column family oriented database. Now let's talk about HBase. We talked about what is CP. CP is, it is partition tolerant and consistent. It is partition tolerant and consistent, but not greatly available. As we told that It's this kind of database. Okay, all all the read writes happen. I mean, at just like the HDFS master, we have HBase master, and whenever any user comes to write, it goes to the HBase master first, and then does the actual writing. So row editing, so the whole row, I mean, a transaction applies on the whole row. Okay, we'll talk about this again. So in the diagram, when we talked about it, so consistency and partition tolerance, this is where H base lies. Okay, this is where H base lies. All right, in the intersection of consistency and partition tolerance. So let me again check. Have I started recording? Yes. Uh, so Shrikant's point is yes. Yes. So this is column family oriented databases basically store Tan and Joe in the nearest location on the disk. Okay, not in the memory. Memory means RAM. All right. So HBase is a consistent and partition tolerant database and is a column family oriented database. Hope that clears you. Now, the way HDFS was based on big table, Google file system, and MapReduce was based on Google MapReduce. Similarly, HBase is based on something called Bigtable from Google. Bigtable is the place where Google keeps lot of data in their organization. So for example, the crawl data, the where the Google crawlers upload the data is stored on Bigtable. So Avdesh is not able to hear my voice. So are others able to hear? Hello? Okay. 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 So what is crawler is? Let me explain crawler again. So a crawler is uh, basically a software as well as basically a software which goes to a website, downloads the whole HTML content from the website, then finds the links in this website. A link is represented at ahref, right? Now downloads all the links in this website and then goes back and hits all of these links and downloads the HTML and then goes further and keeps on going again and again. Okay, so it keeps on downloading the whole website from end to end. So it starts at a single point and it might end up downloading the lot of web pages because it keeps on traveling via href. Okay, that is what a crawler is. It understands the web pages, and after understanding web pages it saves the whole page and picks up the links from this page and then goes and hits those web pages. That is a crawler. Now, this crawler has to, because Google needs to keep this data fresh as well as keep on ranking this data based on how many pages are linking to a particular page. So more the number of pages linking to a particular page, the bigger is the rank of that page. And the more powerful the pages who are ranking to a page, the more better the rank gets. So it's recursively defined. So if there is a page A who has got 10 votes, meaning 10 pages are linking to it, its page rank is quite high. And then if this page links to somebody, then that page will get a higher rank from this one. And that is how the page rank algorithm works. Okay, so crawler basically downloads pages, and why do Google does it? To rank pages and provide various kinds of input to the whole organization. So crawler keep on dumping the data into a big table, and this table serves to lots of many people, including Google search, right? So Google Big Table was exactly designed for it. Now Big Table was being used by around 60 products from inside of Google, as per their news in around 6 7 years ago. Now rows are stored on different machines. Okay, I'll go into this detail a little bit. So there are few more features that we'll go into the data model again. Okay, we'll go into the data model again here. Let's talk about it is good for hundreds of millions or billions of rows. Okay, when you have millions of column by billions of rows, HBase is a good candidate at that point of time. If your data is less than that, if you have millions of column or rows only, then there is no point in having HBase. Okay. So in today's session, we'll also go in how do you design your database when it comes to HBase. We'll give couple of examples, and then you will understand what does it mean. It is strongly consistent. It is not eventually consistent, and the transaction is based on row. Okay, we'll go into the details of that one also. So the other thing is there is a automatic sharding into region server. So there is something called HBase master, and then there are something called region servers. So HBase master contains the metadata and the information about the row, while region servers contains the sections of of your table. Big table is stored into regions. Regions are basically sections of pages, sections of sections of the whole table. Right? Now it has got a really good, it basically stores the data on HDFS. Also, it provides API to run MapReduce. It provides API to run MapReduce on top of any database table. All right. And this is basically a really useful thing. If you have a billions of rows, millions of columns, then and you are able to run MapReduce on sections of the table, then nothing. I mean, it is really powerful. Now the next one is the API, Thrift as well as Java. So it provides you basically a Thrift API, the one which we talked about yesterday, the Apache Thrift Service architecture. It provides that, and hence it provides you API in Java by the way of Thrift. Okay. There are things like coprocessor. Coprocessor is something like a trigger that has been introduced. Coprocessor is something like a trigger that has been introduced lately, but is not greatly stable. Now, and there is something called Bloom filters. We'll talk about Bloom filters also today. How do we enforce constraints in column-oriented database? Constraints as in the primary key and foreign key constraints. So, so the bad news is there are no foreign key constraints in case of HBase. Okay, what are the triggers? Madhav is asking. So, in case of a database, there are something called triggers. What are triggers? Triggers can be triggered. Triggers is a piece of logic that can be triggers when you create a table, add a row, update a row, or delete a row, or delete a table, and alter a table. Okay, so there are these kind of events that happen in the database which trigger your piece of logic. So you define your trigger and save it in the database, and whenever any of the table, whatever you have hooked with, whatever change you have hooked with, you will get that in your logic will be executed. Those are called triggers. Almost all databases provide triggers, relational databases. All right. So triggers are basically the piece of code which executes on the server when some change happen in the database tables. Okay. Now something called Bloom filter we talked about, coprocessors we talked about. We will talk about in detail what is Bloom filters. And yeah, I'm going into a little bit more into characteristics. Okay. One is no real indexing other than the row key. So there is only one row index, which is row key. Okay. So row key is the one which is serves as the index for you, as well as columns also serve you as the index. A little understand when I give you a couple of more examples. And there are no secondary indexes. Okay. There are no secondary indexes. Only one index is there, that is only on the key. As we described NoSQL databases, every row is supposed to have a key, and that is what we call row key in case of HBase. Okay, so that's the only index we have. Now, automatic partitioning meaning after your table. So initially, when you start creating the database table, there will be only a single table. As you keep on adding more and more rows into this table, and it goes beyond a certain threshold, which is a configurable threshold. As that table grows beyond that threshold, the table is split into two equal halves. Okay, and then it gets moved onto two different machines. So that this section of rows, the row subset, is called a region. Okay, so this is called this is basically known as automatically partitioning. And and it scales linearly. There are other reasons why would the balancing and partitioning would matter a lot. You may be adding more nodes into the network, and there could be multiple reasons on one server. They will be moving from one server to another. Okay. So so each table is split it into regions. Regions is basically a subset of rows, and these regions keep on balancing from one machine to another, just like blocks balance in case of HDFS. All right. Now, the other characteristic, just like any other scalable system, it runs on commodity hardware. That does not mean cheap hardware. Okay, most of the clusters are built with 1,000 to 5,000 kind of uh, dollar. I mean, 60,000 rupees computer rather than few lakh rupees computer. Okay, but that does not mean we would put something like a 5,000 rupees computer in the network. Okay, because if you buy really cheap hardware, what happens is the data bus will have some problem after some time. Maybe the power supply is not good enough, and maybe there would be other kinds of problems from time to time, such as fan will be cheaper, fan will start making noise, or fan might stop in between. So in case you are building your server or your network, even some hobbyist plan to put up a network at their home, be careful not to buy too cheap machines. If you buy too cheap machines, they will make a lot of noise, they'll generate a lot of heat, and and the data access, even though you have put a really brilliant hard disk, the data access might be really poor because the cable connecting the hard disk to the motherboard might be of cheap quality. Okay, so you need to be very cautious when you are building your solution. So similar is the case here. That's a general thumb rule, not only specific to HBase, but it's a general thumb rule. Okay. So fault tolerance is there since there are a lot of nodes containing regions, and this data is anyway stored on HDFS. So even if some nodes die, you always have the backup copies of each and everything. Okay. And batch processing, as in your MapReduce is there, which you can run. I'll show you an example, quick example of what does a MapReduce looks like. So here is your HBase architecture. All right. So at the bottom, you see the HDFS. Zookeeper, we'll talk about. Okay. So there is something called a HBase master. Just like HDFS name node, you have HBase master and you have region servers. Region servers each contain something called H file, memstore, write ahead log. Write ahead log is something you keep on writing into the memory and it keeps on flushing it to the disk. That is called write ahead log. Okay. So you imagine there is a big pipe, you keep on writing into this pipe which is in the memory and it keeps on flushing it into the disk. That is generally called write ahead log. This is great when you are trying to, when your write speeds are faster, write speeds are really faster. Okay. Because if your writing is happening byte by byte, it is safe to write block by block. So when you are writing into the disk onto the real physical hardware, what happens is you always, if your header writes a lot of big chunk in one go, it's quite faster. Is it necessary that HBase master and HDFS master? No, not necessarily. Okay. Only this HBase master need to be informed about where is your name node. That's all. Okay. So everybody, including MapReduce's resource manager, need to know only about name node and then it will figure out from it automatically. All right. Now, HBase uses HDFS to store its data, and we'll also show you how is this data located. Okay. Now, HBase has got an API which accesses which provides the access to the data in a very neat manner, very neat manner. And this API basically is Thrift API, Thrift API, and which translates into hundreds of languages. Okay, so you have got master and region servers. Region servers contain portion of the tables. Okay, row 1 to 10 go into first region, row 11 to 20 go into another, and so on, just for example. All right. So there, those are the regions, and regions keeps on balancing between various region servers. If one, if they you remove one region server, then that regions will be made available on another one. If you add one more region server, the regions will balance. That kind of region, that kind of balancing keeps on happening. Okay. And internally, each region server has got something called HBase file. HBase file is stored into HDFS, which contains the actual value, and they've got memstore and there's write ahead log. We'll show you how does it look like. We'll not go too much into details of how exactly it writes. Now there is something which we haven't talked is Zookeeper. Okay, so Zookeeper is essentially a network service. Okay. Now, before I describe to you a zookeeper, let me ask you this thing. How many of you have written a multi-threaded code so far? Okay, Vishal has, and Madhav has, okay. Shrikant, good. Okay, good, good, good. So when we talk about most of the distributed cases, what happens is, let's imagine this. So there is a program which checks an inbox and takes some action on that inbox. Okay. So let's imagine that there are some rules, server side rules on everybody's inbox, and those have to be executed. So somebody need to check these inboxes, right? Now, this process for checking the inboxes and processing it should be run on multiple computers so that millions of inboxes can be processed in parallel. Okay. So basically, on the behalf of users, this service checks the inboxes and then it takes the action. Now, while one of these machines is checking someone's inboxes, the other machine should not touch that inbox. Okay, so they require coordination, right? Similarly, in case of HBase or any other example, for example, you are writing a crawler you're writing a crawler, you are hitting nobigdata.com, you're downloading it. And this crawler is running on hundreds of servers parallelly to hit millions of websites parallelly. Okay. So all these hundreds of machines on which these instances of crawlers are running, they need to keep informing each other that hey, I am hitting nobigdata.com, don't hit. Okay, so that kind of information need to be shared between these different computers very at a very fast rate. Now this kind of coordination was very easy when you were doing multi-threaded programming on a single computer. You just create mutex and you start doing it. So this kind of functionality of coordination was provided by the compiler for you. Okay, the Java virtual machine provided you. For example, in C you have monitors. In case of Java, you have mutex, atomic variables, and so it is fine as long as you are not running this code on multiple processes as well as multiple machines, right? So two things can happen parallelly, either using threads or using processes and processes having multiple threads and a combination of all. And third one is on multiple computers. So if you have multiple computers running multiple processes having multiple threads and they hitting a particular website, there is a need of coordination, and that coordination can only be provided by somebody which is in the network. Something which is local cannot provide you that kind of uh, coordination between multiple computers, right? Because it has that variable, that it's like a the coordination, the way the coordination happens in the real world is using traffic lights, for example. So you have a traffic light, people look at the traffic light, if it is red, don't move, if it is green, start moving. So the traffic light is the information shared with all the people who are standing on a traffic signal, right? So similarly, whenever you are doing a distributed programming, you require a coordination service amongst multiple threads or multiple nodes, multiple machines, multiple processes, multiple threads. Okay. So that coordination system is provided by a very highly available service called Zookeeper. We'll talk about Zookeeper in the next session, but the introduction was must here. Why do we require Zookeeper? Okay. So everybody is clear that why do we require a coordination service in case of distributed application? No? Okay. Now, so that is what is provided by Zookeeper here, the coordination between master and the reason servers. If master has to tell something to reason server, it either can tell directly or it can convey it via Zookeeper, from which these reason server will be communicating. Similarly, if reason server 1 has to inform something to reason server 2 or master, they'll coordinate by the way of Zookeeper. Okay, you can think of Zookeeper right now as a whiteboard on which all master reason servers are allowed to write and read from. Now, let's talk about the data model. The data model is very important, probably the most important idea to understand whenever you are talking about a new kind of databases. Although these column oriented, column family oriented databases or columnar database, tabular database, all the same name for the same thing, might look like a table to you at first, but there is a huge difference in the way the data is organized. There's a huge difference. You need to think. There's a huge difference in the thinking when you're planning to build your data model. All right. So therefore, you need to understand the strengths of the database you're working on, the weakness of it, and that you can understand only if you understand the data model. So HBase is basically based on a database called Big Table from Google. Now, this is a single line which this is a single line which essentially describes everything, which describes the whole definition in a in 5 words, 6 words actually. Big table is a sparse. Sparse means imagine a table containing 100 columns, out of which only two have values. Only first two have values for the first row, then second row might have only one value for something. So it's like a sparse matrix. If you look at the table, most of the cells are empty. Okay, that is a sparse table. Okay, so big table is a sparse and then distributed. What does it mean by distributed? It's it is basically being served by multiple computers to you. Okay, it runs on multiple computers. Persistent, what does it mean by persistent? It is even if there is a power goes off on a computer, it is available. Okay, so it is actually stored on the disk. That is persistent. Multidimensional as in more, I mean, you can have just like um, just like a tabular structure and relational is a multidimensional data, similar big table is also multidimensional. We'll show you a couple of examples and you will get the hang of it. And sorted map. Map is what? A key and the value pair. So now you can, let's go back from the map towards back. So you can imagine you got a huge map in which is order. Huge map means you give the key, it gives you the value instantaneously, right? You give the key, it gives you the value instantaneously. That is what is map. Okay, now this map is sorted, meaning its keys are ordered, which means if you find out a location of one key, then the next one is going to be the immediately next one in the row. So it is ordered. Now, multidimensional means the key can be defined as key 1, comma key 2, comma key 3. So that is multidimensional, right? Now, persistent as in the hash table is located onto the disk, and distributed as in the hash table is served by multiple computers, and sparse as in not necessarily same key has value for other values. I'll give you a more example that will make more sense. Not only that. So, so this is like two two condensed definition. We'll go step by step. HBase has got a concept called tables. Tables basically HBase organizes data into tables. Tables names are strings which are safe for the file system path. Okay. So which means table names are very, you know, table names should not contain if it is on should not contain special characters, and table name should be printable characters and all that. Okay. So keys should not necessarily have values. Keys can have null in that. Okay, good. So in table there is a concept called row. Row is little different idea. Row is more like a key value pair. Within a table, data is stored according to a row. Row has got row key. Each row is identifiable by the way of row key, and row keys do not have the data type, which means even the row key itself can be a binary data. That is something very unique. Okay, so the key does not have to be a printable text the way it used to happen in case of other systems. Here you can have a video file as the row key. Okay. So, yes, row keys are unique and row keys are ordered, meaning, so whole table is organized by row keys, and if row key and the order remains consistent. Okay. So how do we order video files? By the bytes. Okay. So if you have got 2 byte string byte array, you just compare zeros and ones, and you can say the first one is better than them. Okay, so for example each video can be like this or can be like this, right? Now you can clearly see that this one is bigger than this one, right? So it will come like this because row keys are ascending in nature. All right. Now after table and row there is a concept called column family. Column family is collection of columns, and data first grouping, the first level of grouping happens that there is something called table contains rows contains column families, and column families contain columns. Okay, data within row is grouped by a column family, and column family impacts the physical arrangement of the data. Okay, as we talked about, this database is column family oriented. The way the data is physically located is impacted by column family. All the data inside a column family, inside a region is a subset of rows, inside a region, inside a column family is stored together. It doesn't go onto a different machine. Okay? they must define they must be defined upfront. So while you create a table, you should be creating column family then and there instead of later on. Okay, you cannot alter number of column families at a later point of time. So when you're describing your table, you should define your column families. At least you should give their names upfront. Okay, every row in a table has the same column families. Okay, every row has got same column family. That doesn't vary, while columns in a row can vary. Okay, columns in a row can vary. That's what sparse means. Now a row need not store data in its in all its families. A row need not store data in all its families. What does it mean? So some of the column family can be completely empty, but it needs to have the column family. It will have the same column family structure. It cannot have additional column family in that. Okay. Now, and column family is as a name because as I told you that based on column family the storage will happen. The name of the column family need to be printable character, not the binary. While row key can be a binary data. All right. Now the next level is column. Okay. Column identifier or simply column. Okay. It's a within a column family you can have infinitely theoretically infinitely many columns, and they are to be prefixed by a column. They are addressed by or identified by column qualifier. Okay, so whenever we say my column name is age or my column name is id, it's basically the column. All right. Now similarly, just like row key, the column also can be bytes. All right. So table name and column family name need to be printable strings, while row identifier and column identifier can be binary data. All right. And they are always treated like bytes. Now cell is the actual place where you store data. So for a table, for a row, for a column family, for a column, we store the data in a cell. Okay, this should be very clear, right? So in a cell, so for a row, for a column family, in a table, okay, and this identifies a cell, okay, and again the values are in bytes. So row identifier is a byte, bytes as in byte array, which means anything can become the row identifier. Column identifier is a byte array, and cell value is a byte array. While column family and table name is a printable text. All right. Now timestamp. So there's something called timestamp also. By default, by default, each cell has got last historical three values with it. Okay, and you can retrieve any of the last three values. So these three values are called, so whenever you are updating a cell, you update it for three times quickly. So last three times it will have that information that this is my change history. Okay, and this is configurable per column family. How many versions it can retain is configurable. So values within a cell are versioned. Version number, which is by default based on timestamp. Timestamp is up to the nanoseconds. If not specified in the right, you can also actually specify this version number or timestamp while you are trying to write, but do not do that. Do not try to attempt it. Okay, it's only in the advanced cases that you try to manipulate the timestamp while writing the value. And similarly, if you do not specify what timestamp you are expecting, what timestamp's value you are expecting for a cell, it will give you the latest value. Okay. And number of versions retained by HBase is configurable at column family level. If your column family is little more important, then you can increase number of last versions to be retained from 3 to some other value, while the default number is 3. Okay, so now you have got how many dimensions? Now you got the idea what when I said multi-dimensional, you have got various dimension. You have got something called row, you have got something called column family, you have got something called version number to identify a cell, a column family, column, version number, and then you get the value. Okay, so here there are more things here, which means a version number. Okay, and table name. All right, sounds sensible to you? Identifies the cell value. Now, in the logical view, this is how a H-base table would look like to you. So you have got row keys 0, 1, 2, 3, 4, 5, 6, whatever you want to keep them, and you have got column families as personal and office. Under this column family personal, you have got name, and the way we address this is personal colon name, personal colon residential phone, personal, and here office colon phone, office colon address. You can see that, and these things are called cells. Okay, and here it shows you that there are two values here and here, which are basically the multiple versions of the same one. So on the Z index or on the three dimensional, you can imagine there are three layers of this table containing the various timestamp values. Make sense to you? No? You can stop me at any point of time if you have any doubt. So this is how a table is organized. Now, important thing to note is although this table looks full, there could be few values missing here. There could be hundreds of columns in a column family for which there could be completely null values, and HBase doesn't mind it. So logical view to the user looks like this, but the physical view is something like this. Okay, same thing. How many of you know what is JavaScript object notation? Who doesn't know what is JSON? Okay, so JSON is a most simplified object format. So this is my object name and Sandeep. So this is the object. These curly brackets represent an object. There could be multiple variable representing my age and so on. Okay. Similarly, we can have areas. Okay, and we could have array. An array can further have another object, or it can have values. Okay, so is it clear? This is the most simplified way of representing an object. So object is represented by curly brackets and array is represented by square brackets. In a curly brackets, you will see keys and values just like this one. Okay, and in array you represent comma separated values. That's all, and you combine arrays and objects to represent a complex object. Okay, so was I able to explain what is a JSON object? Okay, similarly you could have something of this sort here. You know, the office. Okay, N- and again you have the further nesting. Okay, office name is no big data. Okay, and you have got office address somewhere, say Bangalore, and so on. Okay, or it could have the array. So you could keep on defining a complex object this way. That is what is known as JSON. All right. So The same thing what we have described here as a table is actually represented like a JSON under the hood. So you have got the whole thing represented as a curly brackets, and this is the row key. This only represents the first row of it, okay? First row. So for 001 under the personal column family, there is something called name, and name has got a timestamp. For timestamp 1, the value is John. Similarly, residence phone, for timestamp 1 its value is this one, timestamp 2 its value is this one. Okay, so this is the cell value, and each cell value is a function of timestamp, the column name, column family, and row key. For a different, any of these parameters differ, you go to the next one. Make sense to you? Like a directory structure. 001 slash personal slash name slash timestamp, one value is this one. Okay. So this is multidimensional. This is how multidimensional happen. Okay. Also, here there is a minor mistake. Since the column families themselves are sorted, office will come before personal, personal will come below. There's a minor mistake in this diagram. Right? And here also, the columns are also sorted, which means address will come above and phone will go down. Okay. There's a minor mistake, very minor mistake. The other example. Now, so far we always imagined that our number of columns does not have data. The column names itself do not have data, only the rows have data. Columns are just identifier. Or row keys do not have much of the information. But here you'll see that it matters a lot and it plays an important role. Now, this is the example which Google Web Table has given, and this is how they store their information. Okay, so the row key in this case is the reverse of their domain name. Okay, so www.cnn.com, although it's not exactly reverse, it's just the reverse ordering of the parts of the URL. So that is their row key. When they're storing the website's information, when they're downloading the data and storing the website's information into this big table, this is how they are doing. The key is their inverse of the domain name, and this is a very common thing which we do all the time, right? Whenever we have to keep the information of the domain name, we generally keep it inversed. Why? Because if there is www dot, if there is, if there is, let me show you what do I mean. For say mail.cnn.com, right? This, if it is put into the order, it will, when you inverse it, it will become com.cnn.mail, and this domain name will just come next after the www1. www1 will just come next after. So it's easy to find out all the information about cnn.com, because these will always come together, because the table is sorted by the row keys, right? And if you sort these row keys, they will come very closer as compared to something like com.cmm.www. Okay, this will never get in between, either it will come in the beginning or after, right? Otherwise, if you think about the other way, then these two will be very closer than this one. If you sort it in the normal www dot, the usual way. Therefore, if you have to find out all the information about cnn.com, it is quite easy to do it if the row key is inverse of the domain name. Okay, that is why. So why I am describing all of this is when you are organize your data, you are going to organize your data, think about forming the row keys which make more sense to you. Okay, because this will work like a index to you. Okay, this will work like an index to you. Now the columns of this table, first one has there are two column families. One is content of the website. Okay, second is anchor. Okay, now what does it mean by contents? The whole website's HTML content will go into the column family called contents. There could be two columns, there could be multiple columns, say contents.html and contents.pdf. Okay, or contents.mobile. So if you hit the website from the mobile, this is the content you get. If you hit the website from the PC, this is the content you get. So you can keep on adding those columns into this one. But right now, there is only the HTML column here. Okay. Now, that is one column family. Then there is another column family called anchor. So what does it anchor? All the people who are linking to this website, they will go into this anchor. Okay. And what is the column name? The domain name of the website who is linking back to CNN.com. So CNN SI is what? Sports Illustrated. CNN's Sports Illustrated website is also linking back to CNN.com, and the href text they have given is CNN capital. Okay, that becomes your cell value. Similarly, there's another website called mylook.ca. They are also linking to this one, and in case in case there is xyz.com newer website launched, so you will add one more column to the column family called anchor, saying xy anchor colon xyz.com, having this as the text, right? So now when you look at the column family anchor, you will be able to immediately go through all the column names and find out who all are referring back to this website. So note that the cell value, the plain text, might not be very important here, but the column name is very important. So you are adding data as the column name instead of putting it as the cell value. Okay, because you might be accessing this information, say at a point of time you have to quickly find out whether cnsi.com is referring to com.cnn.ww or not. Okay, then you can quickly find out by making a call to this. All right, did I confuse you? I'm sure you will be having more questions on it, therefore I'm waiting for your questions. This is a little more involved example where you need to think about if you are to collect all the data from websites, what all information will you keep? Okay. So implement it as in terms of HBase internals, how it physically stores it, or how is it as an application layer? How would you build your data model? Yeah. So you need to think in terms of exactly this example. First, the values on which you need to do the lookup should become first the row key. If there is a secondary index you want, then it can become the column name as a thumb rule. Okay, and then comes the cell value. And all those columns which need to be accessed always together need to go into a single column family. All right. Now, same thing can be is represented like this in a, like in a hash table model. So row key www.cnn.com, timestamp t9, anchor is this, row key this, timestamp this, value is this. It's like it's a composite key value, composite key and the value kind of a hash table. Okay, these are the composite keys. This is the physical view. Yes, it is mandatory to define a column family. Each table need to have at least one column family. Okay. Again, let me reiterate whatever I told till now. First, indexing is based on the row key. Tables are stored. Table values are stored. Tables are sorted based on the row key. Okay. And each region of the table has sorted row key space. Each region, which is a subset of rows, starts with a start key and ends with the ends key. That's the identifier of each region. Each region is identified by starting key and ending key because keys are always ordered. That is how the region is identified. And even if you are inserting more values into it, only the end key might change. Okay. Only the AND key might change because you are adding more values to it. Now, everything in H-based table is stored as bytes except for column family name and table name. Atomicity is guaranteed only at the row level. So you cannot have multiple row commits. You cannot say update all these rows or nothing. Don't update anything. Okay, so that is not possible when you deal with HBase. You cannot have multiple row commits. Okay, forget about multiple table commits. The kind of guarantee RDBMS provides you, it doesn't provide you that guarantee. And it is and it has a very valid reason. If it tries to do more and more consistency checks, it will become extremely slow, right? Because each table is broken into so many regions and each region is further broken down into column families that if you try to provide all kinds of locking, then effectively you will not be able to provide the high availability and distribution. Okay, so atomicity is guaranteed only at a row level. You cannot have the guarantee of multiple row commits, right? Because in case of a normal database, you can have even multiple table commits and all sorts of transaction guarantees are there. Okay, column families has to be defined at the table creation time. You cannot add or delete a column family later point of time. Column qualifiers are dynamic and can be defined at a right time. Okay, column qualifiers are dynamic as in when you are doing you know the way you are adding more and more rows, you can keep on adding more and more columns. It basically means that. Okay, the way you are adding more and more rows with the data as bytes, similarly, you can keep on adding more and more columns. It's almost equivalent, just that lookup time of the column is slower as compared to the row. You need to have the row key to look up the column values. Okay. Yes. No, it doesn't maintain the region's replicas. Why? Because regions store the data on HDFS that is anyway replicated. Okay? All data model operations return data in this sorted manner. Row key ascending, column family ascending. Whenever you do any data operation, it will return the data in a certain order by default. Okay, so the order will be first ordering will be based on row key in ascending, column family names. So you have two column families, CF1 and CFX. So or CFA and CFZ. So CFA will come first. Then on the ASCII values. Okay. Shrikant, you mean to say when you said also, that means okay, that was implied. Okay. Now, column identifier as in column 1, column uh, 3. So column 1 will come first, column 3 will come first. And then timestamp. Timestamp means based on the increasing value. So generally it gives you the latest value first and the other values later. Okay. And whenever you are querying, it generally returns only one value until you explicitly ask. All right. Now, we talked about these things. Then there is something called reasons. Reasons, although we have been mentioning reasons, let me explain again. Tables are automatically partitioned horizontally into reasons. Okay. So, okay. Each reason comprises a subset of a table's rows. Okay. So, if you have, I think I should make a visualization. So this will basically row keys. These first three might go into reason one, and the second three might go into the reason two. Okay, and each reason comprises a subset of tables rows. Reasons are denoted by the table it belongs to, its first row inclusive and last row exclusive. Remember that. Okay. So when we say this, where is our okay? This AND key. The last row is basically we represent it this way, okay? Which means the last row exclusive means the if we say that a reason is starting from reason is represented as let's say A, comma Z. So this reason will not have the row key called Z in it. Okay. Initially, a table comprises of single reason. So whenever you create a table, initially it comprises of a single reason. And then as the table grows beyond a threshold, okay, it is splitted into two halves. So generally these reasons are of fairly large size. Okay, these are fairly large size, and these are basically these reasons are bigger than the block size. These regions are bigger than the block size. Until the first split, loading is against a single machine. Okay, so whenever you are creating a table in the beginning, before the split, you will be hitting only a single machine, and then it will be further divided onto multiple machines. Okay. So that's what is the reason. And when you look at the physical structure on the HBase, so all of this database is getting organized into onto your HDFS itself, and this is how under the folder called /apps/HBase it stores. not here, under apps. So you have HBase, and here under the data probably it keeps. Okay, I don't know what is this. So under the data, it should have something here. So this is your table. If you go to HBase and you say list, here you see first table, my HBase table, it is located over here. Under this table, this is the column family it has created. This basically created a reason first. Each table has got a reason, and it created a folder by the name of that reason. It create by automatically this reason, and then under cf1 it created that, and this is the data. Okay, so if you say scan first table, scan first table, yeah, so first table has got row my rk and my rk1, and under that there is some more information. It has got only one column family cf1. Okay, and we should also see other table, the one which has multiple column family. So basically this is where your data is located. Okay, so let me just update this one. All right, so this top level is your namespace name. This is top level is your namespace name, and this is another namespace, and it also contains those metadatas. Okay, so everything is in the HDFS. So let me see if any other table has got column family, recovered edit, no. Now let's say my table. This one has two column family. So you can see the both column family have got different files, which means it is column family oriented database. Meaning for each column family, there is going to be a sort of a single file containing the data. Okay, all the columns are in this one. All right. So let's say my table, scan my table, and what is wrong with it? Oh, what is it doing? What is it doing? Oh, I think I had created some lot of data using, yeah, this is the one. So it's a huge data. So if you say scan my table, then that is what you'll get. Huh. So you can see that a lot of columns are being created, has been created already, right? So you can physically see that the data is located in this manner too. Okay. And all right, so now when you are scanning the data, when you basically query the data, there is no direct SQL provided by HBase, but you can use or Hive, or you can use your Pigletin to query the data in the HBase. Okay, but for updating the values, you have to deal with key value pair as of now. Okay, there are emulations of JDBC. Okay, right? So the way you query is you create the scanners over the database. Scanners are just like the cursors in traditional database, and they have to be closed after you finish the use. Scanners return the rows in order, in increasing order of the row key. Users obtain scanner by doing some sort of this command. This is a Java syntax, but similar syntax will be available in other programming language also. Okay, and this scan parameter is starting off the row key and and the row key at which you have to stop. Both are part of the scan. Similarly, which all columns you need in the scan. If you omit columns, it will return all the columns in a column family. You have to specify the column families at least. Okay, all right. And once you are done with it, it will give you basically one reason to one reason qualifying the data. If your row scans are spanning, if your row scan as in your row start and stop are too big that they are across multiple regions, then you will have to do next to get the next set of reason. All right, and as you can see, there is no such thing as conditions. You have to do that condition checks on the client side itself. All right, so this might be a little disappointing for you, but this provides you a great data store. Not really, HBase is not really a great database, it is great data store. All right, now this is the architecture again. So there is a master, there are region servers. Master and region servers communicate with it by the way of Zookeeper. Zookeeper is like a big whiteboard on which everybody is writing and reading from. And now here is the HDFS on which they are storing their data. As we saw in the file browser, our all of data is stored on the HDFS. Okay, and this is the logical view of each region, as in rows are ordered by row keys, and each region is basically a subsection of the keys. And a region server can have multiple regions, and these regions keeps on moving between the machines in order to give you the high throughput and a great backup. All right, so let's take a quick break of 10 minutes and come back at 10:10. Okay, come back at 10:20, not 10:10. Okay, guys, I'm back. Are you guys back? Great. Should we start now? Apurv, Cletus, Madhav, Sanjay, Shrikant, Virana, Vishal. Great. So let's start now. So we talked about region servers, and I hope it's clear to all of you. And this is a quick peek into if you are using Java, this is a kind of library you need to make a call. As in, first you create a config object, then you create hbase config out of it, and then you create a table descriptor, meaning the name of the table you need to provide. And after you have provided the table name, you need to provide the columns which you want. Okay. And then you can basically provide the column family and then create the table. Okay. Once you have the table in place, then basically also you can iterate over using this admin object. You can iterate over list of tables. Okay. Same thing you can do from command line as well as you can do uh, from the any other programming language. All right. Now, if you can write a mapper and reducer on top of any of these tables. In case you want to operate upon the data given by these tables, you can do that. Okay. Also, as part of maps or reduces, you can update the values into HBase. Okay. Using this API. That is something you can't do using Hive. So you can see that the way we extended the mapper earlier, here you are extending table mapper and then writing the function like this. Okay. And same is you are writing a reducer and then when you're is- scanning it, I mean, you're stitching together the mapper and the reducer, you basically provide something called a table on which you want to run this mapper. The way we run our usual mapper reducer over a file, here we are running over a table and a subset of table, a section of the table. Okay, a section of the table. All right. So we are basically running map reducer job over the section of the table, which makes it possible to scan through it. If you do not provide any row key beginning or end to a scan, region scan, then scan is like a cursor, right? So if you just want to run on a subset of the table, you can run your mapper on the subset of the table, or you can run on the whole table. Okay. So this is how you stitch together. And yeah, that's pretty much. So you created my mapper, you created my reducer, and then you used something called init table function, init mapper function, and init reducer function, and stitch that together. Okay. So that is how you do that. And also, HBase provides you something called a REST interface. From the browser itself, you can query the value, and using a post request, you can submit the value into HBase. Okay, and it provides you the security as well, as in you can have authentication mechanism just like any web server, and then you can start working on this. Okay, so if you have to access column cf1 column name in a row 1 for a table my table, you can go to this URL and then access it. Okay, so in Hive or Pig Latin, do we need to create custom Java code to access HBase? So in case of a pig, you have a HBase loader class. If you remember, we gave you a quick example in the presentation where we said using HBase loader instead of using pig loader default one, we say HBase loader. So it is there already in the pigs library. Same is the case with Hive. You have already this HBase catalog as part of Hive, which you can use to access the HBase. Okay. All right. Now that is about our HBase. So a quick thing which might help you in other things also. When you are building any of the such kind of systems where searching is expensive, here the searching is expensive. If you look up for a key, column key or a row key, it is an expensive system, right? So HBase has come up with something called a Bloom filter. Bloom filter is essentially um, having two mechanisms to basically reduce the load on one server. How does it work? Let's say that there is a building, there is a building in which there is a watchman, and this watchman, everybody who has to go into the building has to collect the ID card from the watchman. So this guy comes up and speaks his name, and then watchman gives his ID card, finds out ID card for his name and give it to this watchman, and goes this guy goes into the building. Now, over a period of time, this watchman has realized that there are lot of people who do not have that name come to it. Their name is not found in the database. They come to it. So what we did was we added two watchmen. One watchman who has got pretty sharp memory. Okay. And we told him that these are the letters, first letter of all the people who are signed up with us. Okay. So and in case anybody comes up and who asks for a name whose first letter is not in this list, just say no to him. Okay, so this is what we call as Bloom filter. So Bloom filter essentially adds one layer of one array of checks which makes the searching very faster. Okay, so one person A comes in and say, hey, is my name, is Sandeep Giri in the list? He says yes, S is in there. So let me give you a better example. Let us say we had three keys: Sandeep, Vishal, Vaibhav, and Arun. Okay, all right. And let me pick up something else. Let's say Sanjay, right? So this is the keys we have in first place, right? So every time user comes in, we look up in the keys and return that to the end user. Okay. Now, what we have done is we have formed, we have picked up first letters of this, which is S, V, and A. Now, if a user comes in and asks for a key called balloon, right? Balloon B we do not have. So we can immediately say no instead of looking up in this list. Okay. There could be thousands of keys, right? So instead of looking up in thousands of keys, we can immediately look into this and say no. But in case somebody says Anil, then A exists in this list, which means it might be here. It might be here. So then you have to perform the lookup. Okay. So if it is found here, then we go here. Otherwise, we just reject from this level itself. So Bloom filter is faster and quicker way to find out what does not exist. Okay, but it does not prove if that it exists. So if Bloom filter says yes, then it goes to the actual storage and does the searching. So whenever users are coming for querying for the row key, Bloom filter plays its role by minimizing the row key lookups. Okay, and Bloom filter basically is a memory intensive game where whatever amount of memory is available to Bloom filter, it will consume that one. If more memory is available, it will have first two letters instead of first single letter. All right. So Bloom filter is that kind of thing. And when we talk about this first letter, it is just an example. It is generally a hash code. Okay. And this hash code you can cleverly design for yourself. It can be summation of all letters and divided by say 100, divided as in modulo by 100, which means it will be from 0 to 100 the values of it. Okay. So right. So or you could also form this hash code in multiple manners, right? So first query comes in as part of Bloom filter, you quickly look up into the hash code, which is a smaller array. And if you found in the hash code, then you go and look up in the actual database. So statistically speaking, Bloom filter decreases the load on the database drastically. All right. So is Bloom filter clear to you? Bloom filter is not a concept which is specific to HBase. It is a general algorithmic technique to to first distribute the searching load. Whenever there is a searching, you can distributed the load from 1 to 2. Second, it makes it really really fast to drop the fails. Okay, if there is keys don't exist, it is very easy, it will quickly find out that one and give the answer quickly. Okay, so that's what it is about. So is Bloom filter clear to you? Great, great. Now let's go to HBase shell. You can basically go to the command prompt here and connect to Hadoop one and then say HBase shell. Now first of all, we'll have something called status. Let's say what's the status. If region servers are down, it will give an error. It'll say 3 dead and 0 servers. Okay, right now we have 3 region servers up and alive. Okay, now next step is that you create a table with multiple column families or a single family. So create the table name and then my column family. This is my column family. So let's call it 8 November. Okay, so it's created. We can say scan my table 8 November. Okay, right now there is no value available. Similarly, list gives you all the tables, and there is list star. You can do regex over here. So as you must have noticed that learning regex was a good idea because almost every component has the regex thing. Okay. Now in this table called my table 8 November, we are adding few values. Okay. We're adding few values. Now it's added my table 8 November. Now you can see that it has got, when we were adding the value, we gave a row ID, we gave a column family name in which we want to add, and we added one column here. We can keep on adding more and more columns to it, as many as we want. Okay, because although we have not defined any of the column so far. Okay, now any arbitrary name we can give. Let's see if basically it has the null value designed also into the system. Okay, my table 8 November, right? So you can see that for a null value, for a blank value also, it has kept the values. So you can keep on adding it as much as you want. Okay, now if you do scan, and here it is showing you the latest value. Okay, 1235. Okay, similarly we can say my table 8 November, and we can also say this, right? Now it shows you all of these values. Similarly, we can say describe just like MySQL, and it will give us the detail about what is there inside the table. It says that this table has got column family as myCF, data block encoding nothing. If you do zipping, you can do the encoding, and the whole column family will be encoded together. And Bloom filter on the row is enabled. Replication scope is not there. Versions 1, and all of this is available. Okay. If your table has got a high demand, you can mark it in memory. Okay. So it will be in the memory loaded. Now, when you are deleting a table, you got to first disable it so that its access is curtailed to all the readers, and then you disable it, then you drop it. All right. Now, so can we see this data in JSON format? Okay, so the way it is stored is not really JSON format. The idea was to give you another representation of the data. The way it is stored is in this format, is actually the binary data. Okay, the idea was just to give you the structure. Instead of tabular, it's this way. Okay, ideally I should change that JSON. I'll here, instead of confusing here, this one, we'll convert it into a directory structure. That will be a better way to represent it. The idea here was to say that this is how a better way we can sparsely represent the data. So yeah, so here when you say scan, sorry, describe, let me show you what happens. Right? So the describe is telling you about the column name. but it is not telling you about the sorry, it's telling you about the column family name. It doesn't tell you anything about the column name or row keys, right? Why? Because just like row keys, the the column names can also be bytes and can also vary as the data gets added. So that is not part of the definition of the table. So Sanjay, this is what the table is. If you see scan my table is what is the table is. You can see it's a huge table, and this is how it is represented as key value pair. All right. Now let it stop. So here there are two column families. One is A's, CF1 and CF2. It's not stopping. So okay, you can see there are for this particular row. Okay, for this particular row, you can see that there are two column families, CF1 and CF2. CF1 has got a name as one of the columns, and CF2 has got one column called age. And this moment of time, they were updated with these two values. Okay, so for name is Sandeep 159890, and the value age is that one. So I had programmatically added all of this from the cell itself. So version is the timestamp one, as you can see. So this timestamp is what is the version number. All right. Hello. Yeah. So how is the timestamp taken? Timestamp is taken from the local machine timestamp. So whenever we have date and date dot on Unix, you have something called okay. So even if there are two versions, you will always get the data with respect to the fresh one. What we can do is we can have a look at the get function. Okay. So the get function has got a key, row, and the column one, and you can also define something called a version number. Let me have a look at help get. Okay. So when you are saying that the way you can do is you can say table.get, okay, and say row 1, row 1, and for this column value, give me the timestamp equals this one. This is how you can retrieve the values for timestamp. Also, instead of saying that, you can also say versions equal 4. It will give you the 4 versions. Okay, you can try that out. All right. So go through this one. Also, I'll put it as a subjective question. if you have to design a simple Gmail like email storage, and you have to store the data in HBase. What will be the key? What will be the column, families, and column names under each family? And what will be in the columns, okay, in each family? And what will be the columns under each family? And what will be the row key? Row key is done. What will be the row key? Column families and columns for each one. Okay, that's what you have to tell. And before that, you have to tell what will be the tables. Tables, what will be the tables first? What will be the row key, column families, and columns under each family for each of the tables? That is the exercise for this. Okay, that is the exercise for this. And also try to run the shell and try to add lots of columns and see the value on the system. Okay, so this is the subjective question which you have to think and design the data model accordingly. The way we had a web table where we are storing lot of data, similarly you have got this one. Okay, so this is the subjective question, and I'll make it available on the website also, so that you can write there. All right, so that's pretty much about HBase. And when you are on HBase, try to solve this problem, because this data model is very similar in case of Cassandra and other similar databases. So the philosophy, once you develop the way you had practiced, practiced in past, how to model your data into relational databases. Similarly, it requires a bit of practice to convert a problem into a HBase kind of a data model. All right, because it takes some time to digest the fact that columns are also sort of a key. The way rows are keys, columns are sort of a key. All right, it takes some time to digest that fact. All right, so here we are. Now let's start with the next session. We'll go at our pace, whatever is comfortable to all of us, no matter how much delay we get into. Don't worry about it. Okay. All right. So let's start with something called Zookeeper. We have done a bit of introduction about Zookeeper already. Okay. So the coordination service we talked about, the way you have traffic lights on the signals so that all the people can coordinate and do not bump into each other and do not cause accidents. Similarly, when you have distributed applications who are running parallelly and you require a coordination, then you put a zookeeper, which itself is runs on multiple computers parallelly. You put a zookeeper so that all these services will be asking the zookeeper, and zookeeper will be replying, right? So and by the way of zookeeper, they will be all talking. So zookeeper, to fulfill this kind of a distributed coordination service need for various distributed application, it exposes a simple set of primitives, very simple set of primitives, because it has to act like a whiteboard where people can write onto it quickly and others can read from it. The only thing is, it should not happen that when one person is writing, other starts erasing the same thing. Okay? Say one person was erasing or one person has already written, you also start writing over it. That should not happen. Okay? So it's a used for synchronization. It does not suffer from race conditions and deadlocks. Race conditions, as I told you, one person writing, another person erasing it, thinking that it's writing it, it's erasing its own stuff. Okay, that should not happen. Okay, when multiple people are working together, there are high chances that multiple people are basically uh, overwriting each other, okay, or deadlocking each other. So this service does not suffer from deadlock or race condition. It exposes a primary simple set of primitives. It's really simple to program to, and it uses a data model like a directory structure. You have got a very simple uh, tree like a structure where you can save any data. So if you had just one place where you can say set key and values, then if there are multiple programs they who are accessing it, they would like to abstract each other. Okay, right, you're right, Sanjay. So race conditions deadlock come into picture generally when there are writes also. If there is only simple reads, everybody is reading, then the conflicts won't arise. You're right. So zookeeper basically helps you synchronize. Okay, helps you synchronize so that you don't bump into each other. And what you should not be doing with zookeeper? Zookeeper is not your data storage. It's a very small data storage. It's a very small, it's for only small data. It's not for big data. Zookeeper is just to store very small data, but it is highly available, and it tries to be, it is heavily consistent. Okay, just that it has only very small storage. Okay, so the design goals are same as what we have told in the previous screen. It has to be very simple. Second second, the other design goals are that it is heavily replicated. So zookeeper itself runs on multiple computers. The client who is connected to the zookeeper keeps a TCP connection, and whenever there is something happens on the zookeeper, the client gets informed, and client keeps on sending heartbeats to the zookeeper. Okay, so that zookeeper does not close the connection. And in case the connection breaks, the client automatically connects to other zookeeper service. So all the clients who are listening to zookeeper, they stay connected to zookeeper, and zookeeper knows that people are connected to it. Okay, now zookeeper stamps each update with the number. Whenever whenever you are making an update, zookeeper marks it as a number. I'll show you these things that will make it clear. So first is it has to be very simple. Second, it is replicated, which means zookeeper runs on multiple computers simultaneously. And since it runs on multiple computers, the question arises that if you are connected to zookeeper, what happens when one zookeeper system dies? So your connectivity shifts to another one. Momentarily, you are out of connection. Third, every update is ordered, which means if I made a change now, my change will appear first than the change being done by any other person onto the same place. Okay? It is extremely fast. At Yahoo, the throughput was benchmarked over 10,000 operation per second. Okay? Now, let's have a look at it. Our our zookeeper, and as the name suggests, it is actually bringing the order into this whole zoo of services. Lots of, you know even HBase is now trying to use, sorry, HDFS is also planning to use the zookeeper for its operations now. So we were talking about, okay, so here we have zookeeper, it's running. Okay, and there are so many clients. So zookeeper also has got a server and clients, and basically right now there is only one machine in the zookeeper. uh, as a node, we can add more and more machines to run the zookeeper parallelly. Okay, so you can SSH to it and connect to this. Zookeeper runs on 2181 port, and ask zookeeper, are you okay? It says I am okay. Or you can say, what is your conf? It shows you the configuration what it is running on. Okay. Similarly, you can also ask it all the other details. Is read only, is read write. It's not only read only. Okay. So it has got this admin kind of a mode where you can ask about status. It's quite simple to run. First, it doesn't depend on HDFS. It is completely independent service. And all you need to do is download a latest release and run it. And in case you are running multiple zookeeper nodes to have all of them working together, you need to keep all of them informed about all of the servers. Okay. Now, the data model of zookeeper is hierarchical. So you can write into slash, or you can write onto slash Jew. So this is your key and you can put a value onto it. Similarly, Jew slash duck is one key. You can put anything, and you can also create more keys under any of this, or you can create multiple nodes at the top and you can add more into it. Okay. Unlike the file system, it doesn't have the concept called folders. It has only this structure where one node can have multiple nodes, and node can also has the value. Okay. So I don't think that our hue has any interface to represent for zookeeper. Mhm. So zookeeper client, and if I say ls star ls slash, it shows you the top level nodes. Okay. These are the top level nodes. And if I want to see what is there under X, I can say this. It shows that there is nothing in there. And here we can say, get me all the value, all the information about slash X. It gives you null. There is no value attached, and these are the metadata of that node. Okay. So when I say ls slash, it gives you all the nodes at the level slash is the top level. Under this, we have multiple nodes, Gaurav, for example. And under Gaurav, you have got multiple further nodes called GK, for example. So GK has got another node called GGK, and GGK doesn't have any other value. And we can say get on any node. So GGK has got a call value called n, and if you take go to one level above, you can still say GK. GK also has got a value called n, and Gaurav has got no value. It says null. All right, you can see that. So that is the kind of a data model Zookeeper has. Okay. Now there are these are all nodes. Whatever we talked about slash Gaurav slash GK, they are all called nodes. They have got values with them. And a node can be ephemeral, a node can be persistent. What does it mean by ephemeral nodes? If you disconnect from Zookeeper, the node you have just created as ephemeral will disappear. So this node remains alive as long as your connection is alive. That is ephemeral node. So say for example, I create a node. I create node called 8 November with some value. Okay. It creates, right? So if you say ls, you will see 8 November here. If you say get 8 November, it'll give you the value, right? Now, if I create ephemeral node, I can create ephemeral node by putting e here and say my test ephemeral node. Okay. So we have created this ephemeral node and we can say get ephemeral node, right? Now ephemeral owner, you can see that is the owner there. Now if I just disconnect from here after some time, say after say 10-15 seconds, this node will disappear. Okay, ls 8 November. So right now it is there. It will disappear in few minutes, few more seconds. So that is ephemeral. So if you since I disconnected, so that connection is gone. Okay, it takes some time to disappear because it is waiting for the timeout. Right now it has disappeared. So ephemeral node are those nodes, and by default all the nodes are persistent. The 8 November which we created is persistent node. Okay. Now the next one is, although as of now you might not find ephemeral nodes utility, you will soon see there is that's how you can actually do a lot of communication. Okay. So it is like saying that I'm going to meet somebody and I'm keeping my phone connected to you. In case my phone get disconnected, you should assume that an accident has happened and you should call the police, right? So that is the utility of an ephemeral node. Ephemeral node says that I am connected. If this node exists, that means I am connected. All right. So that is the utility of a ephemeral node. Now there is something called sequential node. Sequential node automatically gets a number, an increasing number. So like here, if we can create a node called create minus sequential, and here, so we can say my value, oh sorry, so whatever you put here while creating sequential node, that will be considered as prefix. So x is the prefix and a number is generated. The first number that gets generated on a parent node, the parent node is this. Okay, the first number that gets generated is this one, 1. If you create one more node here, it'll create x0002 and it'll keep on increasing it all the time. So sequentially it will creating this. And if you mention say xy, so what node will be created? Anybody? Create minus s, and then we provide this. S is the sequential node. We are trying to create a sequential node like this. So it's a 006. So the counter is attached to the parent node. This is the parent node under which we are trying to create the node. Okay. And if you put this, then also the number that node that gets created is this one, right? So whenever you are building a system like what? System like issue tracking system or any compliant tracking system, all of those systems need a central authority to create IDs. They require a central system to create ID, right? In those cases, this comes very, very handy. This comes very, very handy. You can use this to generate a sequential ID. All right. So, and if we go to another node now, let's say, okay, this node doesn't exist so far. So let's first create that node and then let's just create this node and then we will do what? So if we do this, what will be the node's name that gets generated? Anybody? We are trying to create a sequential node in the parent folder 8 November slash x slash. So what will be the actual node generated? It will be slash 8 November slash x slash 0001. 000, sorry, not 1. Okay, and then it will keep on monotonically increasing. You can see that first one is 000 and then it's 1. Okay, now I'm actually wondering, the last time we created a node like this, the first node that got created was different. So let's say ls 8 November. So it shows you that there is no such thing called 00 in this case, while in this case there is 00. Interesting. Interesting. Alright, so default one is actually 00 and then it starts with x1. The first one is 00. It starts from 0. Now, similarly, you get various kinds of watches from the system when you are watching a particular node. You'll get various kinds of watches, just like events. So the client who is connected will get the notification when a node changes in some way. Those are called watches. And all the watches are triggered only once. Unlike the periodic ones, it doesn't happen that way. So at various point of time, what you want is you want zookeeper to notify that whenever there is an any change in this particular node, let me know. In those cases, what you do is you place watches, or you place sort of an event on each of the node which you in the system. All right, those are called watches. And watches can be created. So these are the operations you can do: create, delete, exist, get access control list, get children, get data. All of these methods you can use. Okay. Now you can do a multiple update onto a zookeeper. All these multiple updates will get combined together, and all of them will either fail or succeed. So this provides you a very okay. So practical example of change in node is, say, whenever somebody creates a particular node, inform me. How should I give you a practical example? Now let us say that HBase HBase is using a zookeeper. HBase is using zookeeper to figure out what all reason servers are running. And told zookeeper that, hey, anytime slash region server has one more node created, inform me. So HBase master told region server, sorry, HBase master told zookeeper that every time any new region server comes up, please inform me. Or anytime any of these region server disappear, please inform me. Okay. Now your system becomes very beautifully scalable. How? We program each of these new machines saying that as soon as you go up, you just inform zookeeper that you just create a node in zookeeper, right? And automatically this HBase master gets a notification saying, oh, there is a new region server has come up. Let's start rebalancing. Let's start moving some regions onto this server. So that is one big utility of watches. Okay, did I make sense to you, Shrikant? So will zookeeper be applicable with our earlier example of word counting using MapReduce? It can be applicable. Let's say what you want is you want only one mapper to run at a time. Okay, let's just assume that we got this weird requirement saying only one mapper should be running at a particular time. So what you do is the first mapper which runs informs zookeeper and creates a node, or if there is already a node created, it should wait till that node disappears. Okay. So similarly, all these mappers would be running the same logic of checking into zookeeper and identifying whether to create a node or not to create a node. Now, so this way, only one mapper will be running at a particular time. So that is one example. So in case you have to do a coordination between various mappers or various reducer, you can use zookeeper. But provided your map reduce logic mapper reducer should not time out on you. Okay, if they timeouts, it will kill the service and assume that this particular node is not performing. Right. So there are no update, insert, delete operations in word count, but there could be a requirement. Say as part of map reducing, you are hitting some service, and that service requires only one login at a time. Okay, that service, so you are hitting some database as part of MapReduce, and that database only allows one login at a time. In case you tries to log in more than once parallelly, it will blacklist you. Okay, that's exactly why I used a similar service earlier, to basically make sure that we do not get blacklisted by a particular server. Now in such cases, whosoever comes first, it will inform zookeeper that I am running. So anybody else, any other mapper will not run if there is already a process running. So that kind of coordination is done. Although although there can be read or writes or whatever actually is happening, but for coordination with each other, you might need to have a central agency where which need to be with which you can do the coordination with each other. Okay. Okay, so now there are basically two core APIs available to access zookeeper other than the command line. The two core APIs are in Java and C, and there are multiple APIs contributed by various people in Perl, Python, and Rest. And interesting part is that for each of these APIs, there are synchronous and asynchronous versions available. Can somebody tell me what does it mean by synchronous and asynchronous? We all talk about Ajax, we all talk about synchronous call, we talk about asynchronous call. What does it mean by to you? Right. Synchronous waits for your request to be completed. Asynchronous doesn't wait for your request to be completed. Like when you make a call, right? Exactly. So second transaction will always happen once your sync completes, which means the first transaction completes. While async, they can happen in parallel. Perfect. Perfect. These are the best definitions. Yeah. So so if you have to most of the asynchronous call in the same manner. So if you have got first function, and once it has got a value called v, and then you do a operation called second function, and then you do a v. Okay, now if first function is asynchronous, we will have to wait. This process will wait here, and you will get the value of v. In case first function is asynchronous, which means that this will immediately return. This will immediately return. So that in those times, what you do is you tell first function that whenever you finish, you call my second function, and you tell first function that whenever your work is done, please call my second function. Okay, so that is the difference between the two APIs. This is asynchronous and this is synchronous. Clear? Any questions on sync async? So when you are making an async call, you tell that, hey, I know that you will do it in the background, but could you make run this function when you are done? That's what you are doing here. While in case of a sync, you know that it will return only then your second function is going to get called, right? Apurv, Cletus, Madhav, Sanjay, Shrikant, Virana, Vishal. All right. So in that similar fashion, is my connection down? Hello. Okay. Okay. Perfect. So all the functions like create a node or delete a node, all of they provides you asynchronous also. They provide you a method that please create the node, and whenever you are done with creation, could you call this function? That kind of API. So, like here, check for if the function exist, if this particular node exists. Okay, async version of that is check this path exists, and once you are done with checking, could you call my function? This is my function callback. Okay, so that is the async and synchronous. All the API which are asynchronous are basically of this form. They where you pass the pointer to the function saying once you are done, please execute my function. All right, the watch triggers, you can add the watch triggers for all of the nodes, and so and whenever you are making a call like exist, create, update, while you are doing this you can also add a trigger saying please inform me when these things happen. Okay, so and those triggers, when do they get executed, is the trigger of the watch of exists gets triggered when a node is created, deleted, or data gets updated. The watch of get data, when you were getting a data, as you saw in this call, that when were checking for a function whether it exists or not, we were passing our watcher. Okay, so this watcher will get executed when the node get created, deleted, or data get updated. Okay, so we are saying please check if this path exists, and parallelly, silently we are also telling that here is my watcher. So anytime in future, if this path gets executed, created, deleted, or updated, this watcher will be executed. But note that it will be only executed once. Similarly, the watcher of get data function, when you are doing get data, will get executed. So the watcher of get data will get executed in case the node is deleted or the data changes or any of its children are updated. Similarly, get children. Okay. So similarly, get children, the watcher of a get children get executed when when the childrens are deleted, a node is deleted, or it's any of the children are created or deleted. All right. And as we saw, there is something called access control list, so that one process does not bother the another process. It does not you know tries to bother other processes. There is a way to restrict by making the access controls. Okay, just like permissioning, an access control can be based on a digest, basically login password, or it can be based on Kerberos. Kerberos is one authentication protocol, or it can be based on IP addresses. Okay, and access control list is basically a combination of a scheme as in digest, SASL, or IP, or and it's a combination of an identity for that scheme like login or IP address or token, and a set of permissions. Okay, so that is access control list. Now, the architecture of Zookeeper is basically there are two modes, just like you have for any other system. There are all any distributed you can run in a single as well as a distributed mode. Similarly, you have for the Zookeeper, it has two modes. One is standalone, meaning there is only one Zookeeper instance. If you have one zookeeper instance, it's not highly available. If that instance goes down, your whole work is lost, right? Therefore, the standalone one is mostly for testing, not really for the production environment. Then second mode is the replicated. Replicated is when you have multiple machines running in parallel to provide you the zookeeper service. And the cluster of machines who are parallelly running Zookeeper are called ensemble, right? And these are very highly available and they tolerate as long as there is a majority. Okay. So, okay. So basically the best place to read about Zookeeper is the central, their main location, the main manual. So, no, Shrikant, you can ask the question in case there is something I messed up. You can ask it. But most of it actually is available very nicely on their website, as well as the definitive guide of Zookeeper is actually good. Okay, okay. So this is a little bit of theory, and this is a little required very much. So far, all of the servers which we have studied, they had master slave architecture. In case of a Zookeeper, there is a bit of a difference. Here, the selection of the master is automatically happen. Selection of master happens automatically, and sometimes A is a master and sometimes B is a master and sometimes some other machine is a master, and that is what that keeps on happening all the time. That is the difference in this architecture of Zookeeper as compared to any other service. Okay, so when the machines boot up, the first thing they do is they choose a leader. They choose a leader based on the pings received by each other. Okay, at any moment of time, if the master if the master forgets or master starts misbehaving in terms of it's not able to respond to the pings provided by other machines, it has to step down and somebody else become the master immediately. Okay, so that is where first that's the first thing that happens. So leader selection happens first, then majority, as in most of the servers, majority means more than 50%, synchronize their state from the leader. And what is the difference between, why is there a difference between master and the followers? So there is a master who has been selected by all the nodes, and there are followers. Rest of the machines are called followers. And all the changes happen on master, and changes are propagated to the followers from the master. Okay, so all the write requests go to the master always, or the leader always. Okay, so we'll continue from here in the next session. Okay, and we will also talk about couple of use cases of zookeeper, and so that we can take the proper benefit of it. Okay, so zookeeper is one service which does not depend on hdfs, while all the other things depend on hdfs. All right, so that's pretty much for today. If you have any questions, just let me know. All right, any questions here? Also, you can start contributing to the forum. I'm trying to make it active and answer more questions over there over the week. And right. So right now we have few quizzes, and what I'm realizing after few people in our class told us that instead of quizzes, big subjective questions, can we convert those into an objective questions? So we are working hard on converting and preparing more and more objective questions rather than subjective. Okay, so if in the first session you have one quiz, in the second session you have a subjective assignment, third session you have subjective assignment, fourth session you have basically you know, not many. Okay, in the fifth session you have a subjective assignment, and sixth one also there is a hands-on assignment. It's a very simple one. You just have to do the things and take the screenshot and send across. So those are the main ones, and I'm trying to convert other subjective sessions uh, into objective ones. Okay, so please look into that and complete your assignment. That will help you a lot. That will help you a lot, and also that will also help you understand what is it that you missed. Okay, in those cases you can quickly ask that, hey, can you explain this part again? I think I have missed this part. So, so feel free to do the quiz now so that I have some bandwidth to explain things. Okay. All right. Please finish all of this over this week. In case you get stuck, drop me an email. I'll immediately look into it, and then we'll discuss. Okay. Good night. Have a good day. Let me save the chat if we can. Save the chat. Save. Good night, Cletus, and have a good day. Have a good week ahead. Is it? Oh, I didn't know. Let me check. If it gets saved into documents, nothing like it. But I doubt, I don't think it gets saved. It doesn't get saved actually, I know. This is what we have saved just now. and this is the previous one. Previous is in 20th September, long, long back. It doesn't get saved automatically. Okay, have a good day. Bye bye.